right, in this video we're going to look at disaccharide. Okay, di, I hope you know, means two. And as I've already mentioned, another name for disaccharides are double sugars. So how do you make a double sugar? You take two simple sugars, two monosaccharides, and link them together. Now the wonderful thing about biology is once you learn one process, you see it over and over and over and over again. So what process have we already talked about that's used to take two smaller molecules and link them together? So what process have we already talked about that takes two smaller molecules and links them together? And hopefully you're thinking dehydration synthesis. So we're going to see our old friend again. All right, here we have one molecule of glucose, right? And here we have another molecule of glucose. And I switched to yellow, but I think I want to go back to blue. All right, so this molecule of glucose, let's make sure it's glucose. There's carbon number 1, 2, 3, 4, 5, and look at 6 does not get to play ring around the rosy. Notice carbon 1, 2, carbon number 3, the OH is different, right? Carbon number 3, we have a hydroxyl below the ring. Carbon number 2, a hydroxyl below the ring. Carbon number 3, a hydroxyl above the ring. We're back to below the ring. All right, same thing on our other glucose. All right, we have carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6 is above the ring. It could have been below the ring, but it's just drawn above the ring. And the hydroxyls, they work, right? 1 below, 2 below, 3 above, 4 below. All right, I'm just showing you it's very consistent. All right, so we have the same old story. We have two stable families, but Miss Hydroxyl and Mr. Hydroxyl here, whatever, they meet at work and they develop a thing for each other. So, I'm sorry, this H and this OH decide to elope. So the HOH leave, and and form their own stable unit, and as you know, HOH is the same as water. So water leaves, and it's a nice little stable entity. So that means this oxygen atom is sad, right? It's unstable because it only has one covalent bond. In this carbon atom, it only has 1, 2, 3 covalent bonds. So the oxygen reaches out and bonds with the carbon, and there you have it. Where we used to have two stop signs, now we have a pair of sunglasses, so to speak. So where we had two simple sugars called glucose, we now have a double sugar named maltose. So you make maltose by combining glucose and glucose by the process of dehydration synthesis. Okay? So I think that's pretty simple and straightforward. Now I added the next slide. Sorry, it's sort of a boring slide, but I added it because otherwise I'd forget to tell you this. So when you do your chapter guide, you will see this word glycosidic linkage. So sorry, here's the boring part of the lecture. The covalent bond between two monosaccharides, so simple sugars like glucose, formed by dehydration synthesis, like we just went over, is called a glycosidic linkage. So an interesting thing about a glycosidic linkage, it's always a carbon covalently bonded to an oxygen, covalently bonded to a carbon. All right, so let's see it on the last slide. Remember, this is a carbon. I switched back to yellow. How did that even happen? Well, let's go red, make it dramatic. All right, so we have a carbon covalently bonded to an oxygen, covalently bonded to a carbon. So this is our glycosidic linkage. All right, and now when you have two simple sugars, and I'm just going to draw them like little hexagons, the linkage between them, all right, this is always a glycosidic linkage between the two hexagons. All right, boring part of the lecture. But I will point out, whenever you see the prefix glyco, it means sugar or glucose. So you'll see that word a lot. When we do glycolysis, it means literally breaking glucose. So this is glycosidic linkage. All right, so let's talk about these. There's 3 double sugars you might want to be familiar with. So everything in this column is a disaccharide. It's a double sugar. And everything on the right, these are the 2 monosaccharides that are linked together. All right, lactose, we make lactose by linking together glucose and galactose. So I know you want to think galactose is a big molecule because it's a big word, but sorry, it's still a simple sugar. And believe it or not, just like, okay, you've seen glucose and fructose before in the last video. Remember, glucose and fructose are isomers of each other. Well, guess what? Galactose is another isomer. All three of these simple sugars have the formula C6H12O6. All right? So these are three common simple sugars: galactose, glucose, and fructose. All right, so when you link together glucose and galactose, you get lactose. And I bet you've heard about lactose before, all right, because you might know somebody who's lactose intolerant. So let's break this down. Lac, L-A-C-T, means milk. You can fake your way through so much of biology if you know what the prefixes and suffixes mean. Yeah, I can write. So lac means milk. A lactating woman is a woman who's breastfeeding her babies, all right? Lac means milk. Lactose, well, OSE, do you see all these oses? Lactose, maltose, sucrose, okay? OSE in biology means I'm a sugar. So whenever you see the suffix OSE, that molecule saying, I'm a sugar. Just like, remember IDE? That means I'm a negative ion. You're not allowed to forget anything in biology. All right, so this literally means milk sugar, lactose, and that's where you find it. So lactose is made by combining glucose and galactose together by dehydration synthesis. Maltose is malt sugar. It's found in grains. And if you have any family members who microbrew their own beer, they will use maltose, all right, to feed their yeast to brew their alcohol. And I already showed you maltose on the last slide, right? All right, this was maltose we built right here, all right? And as I already showed you, you make maltose by linking two glucoses together. So we've done lactose, maltose, but the most important disaccharide for you to know is sucrose. Sucrose is table sugar. This is what you dump in your Starbucks. This is what you use to make your chocolate chip cookies. If anybody ever still makes their chocolate chip cookies from scratch, 2 cups flour, 2 cups sugar. The scientific name for sugar is sucrose. And how do you make sucrose? You get it by linking glucose and fructose together. So these are all three disaccharides. They're all three important, but for your immediate quiz, sucrose is absolutely the most important from it. So in class, we will cover polysaccharides, but I forgot. I have a little summary slide on monosaccharides and disaccharides. So monosaccharides and disaccharides are formally known as sugars. So when somebody says that's a sugar, it's a monosaccharide disaccharide. Polysaccharides ain't sugar. All right, all these sugars end in OSE, and I told you OSE means I'm a sugar, so we're good there. One thing about mono and disaccharides, they're all highly water soluble, also known as hydrophilic. This was from your lecture guides, if I can spell hydrophilic. All right, that literally means water loving, but scientifically it means water soluble. So all monosaccharides and disaccharides are hydrophilic, water loving, which means they all dissolve in water. And they taste sweet to humans, which is why we like them. So there you go. You're bored this weekend. It's a nice weekend, and you're listening to this biology lecture, and you can say, hey, Mom and Dad, guess what? I got my tuition dollars worth this afternoon. I learned that sugar dissolved in water, and it tastes sweet. All right, maybe that wasn't news to you. All right, but if you really want to mess with your mind, think about this. Why do sugars taste sweet? It's called evolution. Because the humans and the animals that eat sugar because they liked it, they could use sugar for cellular respiration, right? If you didn't eat sugar because you didn't like it, where would you get the energy? So this is really not an accident at all that sugar tastes sweet. All right, so that's enough of me messing with your mind for today, and I will see you in person. Bye.